I'm having another stab at this history of the universe in 5 words: maths, physics, chemistry, biology, psychology. And I'm just thinking about the entities which exist at each of those stages, or within each of those disciplines. You know, because maths is made up of the symbols that maths is associated with, which isn't just numbers, of course. It's all the various operators and entities that exist within math. Physics, yeah, I mean, certainly, yeah, the way that we talk about physics, or the way that, oh God, I can't really describe that. Yeah, physics. If you look at something like particle physics, for example, it's you know, it has a particular menagerie attached to it. It has, you know, the quarks and the bosons and the leptons and the electrons and photons and all that kind of stuff. So it has its menagerie. Chemistry has a similar menagerie, which I mentioned in the previous one, captured in the table of elements. Biology kind of has a menagerie. Well, we've certainly got a menagerie around us, and we've got some history of what the menagerie was like in the past, and we can make some possible speculations about what it might be like in the future. And psychology, we haven't really got a menagerie at all, or we haven't got an index of possibilities that exists within that discipline yet, at least. In some ways it's a shame, because I think it'd be really great if at each level there was, well, not just the discovery of what kind of things exist there, but the logic for why a certain number of things exist there and why they are the way they are. And here I guess the default ideal would be one I mentioned in my previous video, which is Mendeleev's table of the elements, which are the underpinnings of chemistry. And the thing about the table of the elements is that it's not just a kind of random list of chemicals from hydrogen through to the various what are they called, the transuranics, the radioactive elements down at the bottom of the actinide, lanthanide series down there somewhere. It's not just a list, it's a list which makes sense in terms of the physics of those particular elements. You know, when Mendeleev made the table of the elements, a lot of the elements, you know, probably only about half of the elements we have now were known about. But because there's an orderly system to what elements can exist, determined by the physics of those elements, that when he drew the table he could just leave gaps. You know, he said, oh, there's bound to be a chemical here because the physics determines it, and there's not going to be any elements that's simpler than hydrogen, because that's the physics of hydrogen is like this, and there's not going to be any chemicals, commonly occurring chemicals, you know, beyond the bottom ones here, somewhere near uranium. I mean, he didn't say this, but this is the logic of it, because the physical constraints of how these things are put together determine that. So you've got a completely constrained menagerie, a completely constrained list. It's not a random list, it's a list which is determined by the physics, which is very attractive, I think. And to a certain extent, I think the same is true with something like subatomic particles, determined through mathematics, but which make up the menagerie of physics, in a parallel way to the table of elements makes up the menagerie of chemistry. Where the hell am I? Oh yeah. I think we can get in this way, but there's a great talk on one of the TED Talk series by this guy, I can't remember his name now, but I'll find it and put it on the sidebar, in which he proposes this model of mathematical model for how the subatomic particles exist and which ones can exist. And it's based on I think it's 7 or 8 dimensional mathematical rotations, leading to this, what he calls the E8 figure, which is this really beautiful multi-dimensional mathematical object. But it seems to function in the same way that the table does in Mendeleev's table of the elements. It makes predictions about which atomic particles can exist, even the ones that we haven't discovered yet, or the ones that we've proposed but haven't actually found. And I don't know if he's right or not, but something like that, I would guess, must exist. There must be I guess, a logic which provides a constraining structure for how big the menagerie of physical particles could be. in the same way as I say of Mendeleev's table of the elements. The same doesn't seem to be true, at least if it is true, I don't know about it, of in biology. There isn't a table of possible biological forms. It'd be great if there was. I mean, I presume there is some kind of limit. The human genome or the animal genome or the plant genome is a very, very complex entity. And there seems to be a multitude of ways in which it can be put together. And the constraints upon it are not internal, or not solely internal, they're partly determined by the environment, which is a highly dynamic and flexible system itself. So I don't know whether there is a kind of logical limit. I don't know whether you could kind of tabulate the possible life forms that would exist within some kind of biological version of the table of species or something. I don't know even how you can describe that. And as I say, when you get to psychology, I don't know, maybe there's a way of tabulating that, or kind of graphically imagining it in some way. I'd certainly like to see that.